Hello everyone, welcome back to our channel. In previous session, we have seen the manual setup of AWS VPC Transit Gateway. And in today's session, we'll use Terraform to set up an AWS VPC Transit Gateway, which will enable seamless connectivity and communication between multiple VPCs within our AWS infrastructure. So before we begin, there are some prerequisites you should follow. So you should have AWS account with necessary permission. Then you should have knowledge of AWS VPC concept as VPC, subnet, route tables, and security group. And you should familiar with the AWS role and policies. And these are the table of contents which we are going to learn today. So let's start. So what is AWS VPC? So AWS VPC is virtual private cloud. So it is a service that lets you create a private network in the AWS cloud, which is isolated from other networks. It allows you to define your virtual network environment, including IP addresses, subnets, routing tables, and network gateway, giving you control over network configuration and security. Now let's understand about what is AWS Transit Gateway. So AWS Transit Gateway is a service that simplifies network connectivity for multiple Amazon virtual private clouds, VPCs, and on-premises networks. It acts as a hub that allows you to connect VPCs and VPN connection, enabling centralized management of network routing and traffic between these resources. So this simplifies network architecture, improves scalability, and reduces operational complexity by providing a single gateway for routing traffic across multiple networks. So in previous session, we have learned about the example having multiple Amazon virtual private cloud hosting different parts of our application infrastructure like web application, backend services, and shared resources like databases. So you can refer that article which is available on Cost Eclipse. So this is the manual setup as well as I have posted the video on DevOps Hint channel. Here you can find that video. So you can refer this video for manual setup. Now let's move forward and see the steps for setting up AWS VPC Transit Gateway, which include the creation of provider.tf file where all the provider plugins are mentioned. Then we will create our first VPC called as web app. Then we will create second VPC called as backend services, and then third VPC called as shared database. Then we will create EC2 instances, then transit gateway, and then we will attach that gateway. Then we will update the route table for the VPC we have created, and finally we will apply the configuration. And then we will check the connectivity between the VPC, followed by the conclusion. So let's start. So here you can find the article which is available on firstexit.com, and you can also get here the code which I have mentioned here. So let's see, the first step is to create the provider.tf file. So the provider.tf file is in Terraform is a configuration file that specifies the cloud provider and its corresponding plugin that Terraform will use to manage resources in that provider. So here you can find that summary view of the Terraform files in a Visual Studio Code. So I am currently using Visual Studio Code editor. You can also use Atom and other editor according to your requirement. So first I have created the folder called as Terraform AWS Transit Gateway. Then I have created the files step by step. So our first step is to create provider.tf file. So let's move to our Visual Studio Code editor. So here you can find the provider.tf file, and simply you need to copy the code from the article and paste here. So simply paste here and save the file. So basically this Terraform configuration code snippet is for setting up an AWS provider specifying the region and profile to use. So the provider AWS, which will declare that we are using AWS provider for Terraform. And the region I'm currently using is AP South 1, which is Mumbai, Mumbai region. And the profile is set to default, which specifies the AWS profile to use. In this case, it's using the default profile, where we have configured the secret key and access key on our AWS console. Then the Terraform block is used to specify required provider and their version. In this case, it's specifying the AWS provider from HashiCorp with version 5.43.0. So overall, this code sets up Terraform to work with AWS in the AP Southern region using the default AWS profile and ensure that it uses specified version of the AWS provider. Let's move on to next step. So now our next step is to create web app VPC in the Mumbai region. So simply create another Terraform file named as web app VPC and simply copy this code. So let me just remind you, just copy the code as we are only going to create VPC. So below I have also mentioned the code of the route to backend services via Transit Gateway. But just copy the layer, the AWS route initially. So just copy this code and so create the file called as webappvpc.tf and paste your code. So as to create VPC, you can also refer Terraform registry to create VPC, to create subnet. All the code is available on Terraform registry as well as on the article. So to create VPC, we have used a resource name called as AWS VPC, and I have given the name for our first VPC as web app VPC. And the CIDR block, which is IP address, I have used as for our first VPC is 10.0.0.0/16. And the tag name I have given for our first VPC is web app VPC. Next, after you create VPC, our next step will be to create subnet. Then I have created the subnet. So the resource name I have taken as AWS subnet and the name of the subnet I have given as web app subnet. Next, you need to mention the VPC ID here as the subnet is going to create in that VPC only. So that's why you need to specify your VPC ID. So the subnet will create in the web app VPC. Then you need to mention the CIDR block range. So I have mentioned here the IP address 10.0.1.0/24, which include 256 IP address. And the availability zone is set to AP South 1A, which is in the Mumbai region. And the tag name is web app subnet, which is the name of the subnet created. Next is to create internet gateway as it required internet connectivity. So the resource name to create the internet gateway we have given as AWS Internet Gateway, and we have given name for that internet gateway as web IGW, which means internet gateway. And as we need to create the internet gateway in the web app VPC, so you need to again mention your VPC ID. So just you need to specify your VPC ID to create internet gateway in that VPC. Then I have given the tag name, which is the name for the internet gateway as web app IGW, which means internet gateway. Then I have taken the resource name as AWS default route table. So as we have created internet gateway, we need to add the route to enable internet connectivity. So I have just edited the default route table and added the route for the internet gateway to get the connectivity over internet. So first, I have taken the resource name as default route table, and I have given the name for that default route table as web app route. Then you need to mention the default route table ID here. Then I have given the tag name as web app route to that route table. So then again you need to edit that route and enter your internet gateway to enable the connectivity. So simply take the resource name as AWS route and mention here your name for that route, which is web app route, and mention here the route table ID which we have created earlier, which is web app route.id. So just specify here the resource name with the name and .id to create the route for the internet gateway. Then specify the destination spider block, which means that you need to specify the internet gateway IP, which is 000, as it is available anywhere and accessible by internet. Then you need to specify the gateway ID. So we have created here internet gateway. You just need to specify that ID with the resource name as AWS Internet Gateway and the name of our gateway, which is web app IGW, which means internet gateway.id. And here it is depend on the AWS VPC. As all these resources are going to create in the web app VPC, you just need to specify here depends on. So let's move forward. So we will ignore this for now and we will see this later. So our next step now is to create backend services VPC in the Mumbai region. So same as we have performed for the web app VPC, just create another file name as backend services vpc.tf file. And here you just need to copy the code from the article and paste in the Visual Studio Code editor. So same as we have created the VPC for web app, you need to create VPC for backend services. So you just need to change the configuration which we have created for web app VPC. Like you need to specify the VPC name or second VPC name as backend services. Then you need to mention the CIDR block here, which will define your IP address, which is set to 11.0.0/16. Then you have to give the name for that VPC. So I have given the name as backend services VPC. Next, after you create VPC, your next step is to create the subnet. So just I have created this subnet and I have created the subnet in the Mumbai region only in availability zone AP South 1A. Then I have mentioned the CIDR block and the VPC ID, which will consider that the subnet will be created in the VPC created, which is of backend services VPC. Then just I have mentioned the name for the subnet. And again, you need to create AWS Internet Gateway for backend services as well to enable internet connectivity. So here you need to mention again your VPC ID tag. So it is similar as we have created web app VPC. Then we have created a default. We have used the AWS default route table and then we have modified it and edit the routes similar to the web app VPC and added the internet gateway route in the route table of backend services. So you can refer the code from the article. Now let's see the next step is to create the shared database VPC in the Mumbai region. So it is similar. So just create the file called as shared database vpc.tf file and copy and paste the code here. So here you can find the third VPC we have created. So first we have, as we need to create a VPC, we have taken the name as AWS VPC. You can also refer this code from Terraform registry. And I have named the VPC, a third VPC, as shared database VPC. I have mentioned the CIDR block as 12.0.0/16. Then after you create VPC, your next step is to create the subnet. So I have again created the subnet for the shared database VPC, and I have specified the IP range till 12.0.1.0/24, which include 256 IP. Then the availability zone is similar to previous one as AP South 1A, and the tag name for our subnet is shared database subnet. Next, as we need to next step is to create internet gateway to enable internet connectivity. So again, we need to create an internet gateway for shared database VPC. So I have specified the name as shared database IGW, and please specify your VPC ID here. So all these resources like internet gateway subnet will be created in that VPC only. Then again, you need to create it or modify the default. You can also create and modify the AWS route table. So I have used the default route table and name it as shared database route, and I have specified route table ID, and the tag name for the route table is shared database route. And then again, you need to edit the route table of the shared database and specify your internet gateway, the destination CIDR block here, and the gateway ID, which we have created earlier. Here you can find. So just in gateway ID, just enter your resource name here and the name of the internet gateway with the .id. And it is depend on the VPC we have created earlier. So it is compulsory to type this depends on, as it depends on the VPC created earlier, which is shared database VPC. Now let's move forward to our next step. So our next step is now to create EC2 instances in each VPC. So if you go down, you can also get the code for the EC2 instance. So we have to create 3 EC2 instance now. So name it as EC2. So first you need to create EC2 instance for our web app. So I have mentioned the name as EC2 web app.tf. So basically this file will include the security group, the EC2 instance, which we are going to create the name of the instance, the key name, and etc. all the parameters. So let's see. So first we are going to create EC2 instance for our web application. So here I have created the resource name. So first we are going to create a security group, or I have used the AWS default security group and name it as default. Next, as you need to create an EC2 instance in the VPC we have created earlier, so you need to specify your VPC ID. So I am creating EC2 instance in my web application VPC, so I have specified the name of the VPC.id. So this will create the security group in that VPC, and the name of the security group I have given as web app SG. So with the help of this, I can identify the security group and edit the inbound rules if required. Next, I have allowed the SSH access from a specific IP. So I have allowed the SSH access to anywhere. Here you can find the inbound rules, and also I have allowed the HTTP access from anywhere. So here you can find the inbound rules from port 80 to port 80, and the CIDR block is set to 0.0 IP, which means it is available anywhere. And the outbound rules I have allowed all the outbound rule traffic for simplicity. So this was the code for the security group. Let's move forward and now launch the EC2 instance. So to launch the EC2 instance, you need to take the resource name as AWS instance. Then I have simply given the name for that instance as web app Linux instance. So it is just to identify that we are going to create an EC2 instance of Ubuntu. We are going to use operating system image as Ubuntu. So I have given the name as web app Linux. Then you need to specify to create EC2 instance, you need to specify an AMI ID. So which include that different operating system image have different AMI IDs. So just copy that from your AWS console and paste here. And the instance type which I have given here is t2.micro. So as this is eligible for free tier account. So you can use instance type as t2.micro. Then I have specified a key name to enable SSH as we are going to access this EC2 instance using MobXterm tool. So just you can create the key pair and just enter here. Then I have so previously in manual setup done I have pasted this code in the advanced setting of the EC2 instance. So here you need to specify here and the user data and all the code here to install the Nginx, which will give our server, which will specify our server IP. So this script I have explained in previous session. So just copy this code from the article and paste it. So it generally includes the installation of Nginx and it will edit the index.html file of the Nginx and we will and it will display the host name as well as IP address of the instance created. Next I have specified the tag name as the instance as web app Linux instance. Then you need to specify to associate the instance with the security group, you need to specify the VPC security group ID. So you need to specify this by the resource name and the name of the security group with the ID. So the resource name is AWS default security group dot default, which is the name for the security group which we are going to create for web app VPC. Next, you need to also specify here the subnet ID. So this instance we are going to create in the subnet, and here you can find that associate public IP address is set to true, which will enable auto assign public IP as we need to connect that instance and check the connectivity. Next, I have specified the output as we need to display the output of the instance created. So I have simply taken the resource name as output and specify the specify the name. You can also give your name as per your requirement, and you just need to add the value here and the instance as we need to display the instance public IP. So just specify the resource name as AWS instance, then web app Linux, which is the name of that instance, and the dot public IP, which will give the public IP address of that instance. Now, similar to this one, our next step is to create EC2 instance in backend service for backend services. So just create another Terraform file called as ec2 backend services.tf file. Then similar to previous one, we have created EC2 instance for web app. So just create another security group, which I have given the name as default2, which will denote that this security group is created for backend service. Then I have specified the VPC ID name as AWS VPC, the name of the VPC which we have created earlier, which is for backend services dot ID, and specified the tag name of the security group, which is backend services ST. Then again, I have allow SSH access anywhere as well as HTTP as we are going to perform or install the Nginx. So Nginx default port is 80. So that's why I have enabled the HTTP port. Then the outbound rules is set to anywhere which allow all traffic. So similar to previous one, we have launched the instance and given the name as backend services Linux. The AMI ID which we are going to use is operating image of Ubuntu. Then the instance type t2.macro which is available for free tier account. Then the key pair name, you can create key pair name and just you need to mention your key pair name and you need to have the key pair here. And simply I have used the script to install the Nginx. So with the help of this script, you don't need to connect with the instance and then type your code. So this will automatically install the Nginx and display our default page with the host name and the IP address of our instance. Then simply I have given the instance name as backend services Linux instance. Then again you need to associate the instance with the security group, then with the subnet, and just make sure you enable the auto assign public IP to get the public IP address. And then again, which I need to display the output of that instance launched in the backend for the backend services. So again, I have mentioned here output. So now we have created EC2 instance for backend services VPC in that VPC. Now our next step is to create EC2 instance for shared database.pf file. So please create EC2 shared database.pf file and just copy the code and paste in your Visual Studio Code editor. So now again you need to create a security group. So I have given the name as default 3 for the security group and the VPC ID I have mentioned here is of shared database VPC. As now we have finished with the EC2 instance launch with 2 VPC. So our third VPC name is shared database. So you need to specify your name of the VPC. Then the tag name of the security group is shared database H. So you can give the name according to your requirement. Then you need to allow the SSH access from your specific IP address. So you, as I have enable here everywhere, anywhere, and also the HTTP access to any. So make sure that these two rules should be enabled anywhere, as we are going to check with the installation of Nginx. And the outbound rules are allowed anywhere similar to the previous. Then we have simply launched the instance in our shared VPC, shared database VPC, by simply specifying the name of the instance, the AMI ID which is Ubuntu, instance type t2.micro, similar key pair, and just we have added the user data script with the installation of Nginx, which will give the display the host name as well as the IP address of the instance. Then I specified the tag name for that instance as shared database Linux instance. Then again, you need to associate the instance with the security group, the subnet, and enable the auto assign public IP. And finally, the output of the instance. To display the output of the instance, I have written the code. Now let's move forward to our next step. So after creating EC2 instances in each VPC, so our next step is to create the transit gateway. So basically, this step will integrate our VPC web app, VPC backend services, VPC shared database, VPC into transit gateway network, which will enable communication with each other. So in setting up an AWS transit gateway, which is creating transit gateway attachment. So this is our next step. So this step is crucial. So because it It is where we integrate our VPC, specifically the web app VPC backend services and shared database VPC into the transit gateway network. So this integration will allow this VPC to communicate with each other. So now our next step is to create transit gateway in AWS. So now let's create a file called as transitgateway.tf file and just create the transit gateway. So it is simple code. You can also refer this from Terraform registry. So to create transit gateway, you need to specify the resource name for transit gateway is AWS EC2 transit gateway. Then I have simply given the name tag name of this transit gateway as web backend database transit gateway to identify the transit gateway. And the description, I have simply given the description for this is TG web backend database, which include transit gateway web for web backend and database. And the name is example of the transit gateway. So we have created transit gateway successfully. Now, the next step is to create the transit gateway attachment. So what is exactly a transit gateway attachment? So think of it as a bridge that connects our VPC to the transit gateway. So it's like laying down the virtual highways that will allow traffic to flow between these different VPC. So with the help of transit gateway attachment, we can connect the web app VPC to backend services and backend services to shared database VPC and vice versa. So let's create the file called as transit gateway attachment.tf file. So I have created the file and just you need to copy the code and paste it in the Visual Studio Code editor. So just copy this code and paste in the editor. So here you can find, so basically this code will attach 3 VPC to the previously defined transit gateway named as example. Here you can find the transit gateway ID. So simply the resource name which we have given earlier as AWS EC2 transit gateway. So before that, we need to create the transit gateway attachment. So simply we are going to attach the web app VPC to the transit gateway. So resource name as AWS EC2 transit gateway VPC attachment. And first we are going to create the attachment for web app. So simply I have given the name as web app attachment, and simply next step require the ID of the transit gateway. So this ID, which include the resource name for the transit gateway and simply the name which we have given earlier as example. So simply .id. So this will create the attachment which include the transit gateway which we have created earlier. And the subnet ID, you need to specify your subnet ID, which is the reference to for the created subnet ID. So we have created the web app subnet earlier. So you just need to specify your subnet ID. And this transit gateway attachment should be included in the VPC, web app VPC. Then simply I have given the name for the first attachment as web app VPC attachment. So we have successfully finished with the first transit gateway VPC attachment. Next, so our next step is to attach the backend services to the transit gateway. So simple as previous one, we have taken the resource name as APC, AWS EC2 transit gateway VPC attachment and given the name as backend services attachment with the transit gateway ID. So make sure that transit gateway ID will be similar to previous one, as we are not going to create transit gateway different for Next step is to create. Next step is to specify the subnet ID which we have created for backend services called as backend services subnet and specify with that ID. And again, you need to specify the VPC ID to get attached. So this attachment will be created for the backend services VPC, and the name of this attachment is backend services VPC attach. Now, last step for transit gateway attachment is for shared database. So similar to previous one, you just need to specify the resource name here to create the transit gateway VPC attachment, then specify the name for the attachment, then specify the transit gateway ID, make sure it is similar to previous one, and the subnet ID which we have created the subnet for the shared database VPC called as shared database subnet. Then specify the VPC ID as AWS VPC shared database VPC, which will attach the transit gateway to our VPC created earlier, and specify the tag name as shared database VPC attachment, which will specify the tag name for our transit gateway attachment created earlier. Now let's move on to our next step. So let's check our next step is to update the route table for web app VPC, backend services VPC, and shared database VPC. So let's move on to our file. So, so just click on web app vpc.tf file, and below you just need to add the route. Add the route so it can access the. So this VPC will be accessible by backend services as well as shared database. So you need to just create a route for this. So via transit gateway attachment. So we have performed the VPC step till here. So I have told you that we will see this later. So let's check now. So first step is to create the AWS. So we need to add a route. So I have named that route as web app to backend services. So I have mentioned the route table ID, so which will create the route in that route table ID. So our route table name is web app route. And the destination CIDR block I have mentioned here is of backend services, so which is 11.0.0/16. And the transit gateway ID which we have created will be of web app attachment. So this transit gateway ID is of web app. So as we are going to create attachment from web application to shared database as well as for backend service. So we have finished with the attachment of web app to backend services. Let's move forward, and again you need to create a route which will enable the connectivity between the web app to the shared database. So I have again given the name of to web app to shared database and specified the route table ID, the destination CIDR block. So please specify your correct destination CIDR block. So destination CIDR block of shared database which we have created earlier is 12.0.0/16. And you just need to specify a transit gateway ID, which will include the AWS EC2 transit gateway VPC attachment and the name of the first VPC attachment is web app attachment, as we are going to create the connectivity between web app to backend as well as shared database with the transit gateway ID. And here you can find it is depend on the transit gateway which we have created earlier for web app attachment. So this code will enable communication between resources. Now just save the previous code of transit gateway attachment. And so we have finished with the attachment of the web app to backend services and shared database. Let's move forward and do this step in the backend services VPC. So here you can find Here you need to again update the route table of the backend services. So I have created a route. So I have taken the resource name as AWS route. Then again, you need to specify your name. So name I have given as backend services to web app. So again, you need to specify the route table ID. So the route table ID, which includes the AWS default route table, which is the resource name, the name of the route table dot ID. So this will create the route in the associated route table. The destination block. So please make sure as we are going to second step is to create the backend services to web application. So the web application CIDR block is 10.0.0. So this will enable the connectivity between the backend services from backend services to web app. So please mention your correct CIDR block. Then again mention your transit gateway ID and it will depend on the backend services attached. Now next step is to create another route which will enable the connectivity from backend services to the shared database. Again, you need to specify the route table ID and the shared database CIDR block is 12.0.0/16 and the transit gateway ID with the depend block. So it is depend on the backend service attachment. So we have finished with the connectivity from backend services to web application as well as shared database. Now let's enable the connectivity from shared database to web application as well as backend service. So let's move to our shared database VPC. Again, go down and here you can find that we have enabled the route from backend services from the shared database to the web application as well as. So first, we are going to take the resource name as AWS route and here you can find we have given the name to shared database to backend services. So this will enable the connectivity between the two VPCs from shared database to backend services. Then specify the route table ID here with the resource name as default route table I have taken as AWS default route table and the shared database route.id. So this is the name of the route table which we have created earlier and specify here destination CIDR block of backend services. As first we are going to enable the connectivity from VPC shared database to backend services. So you need to specify your IP address of the backend services. Next, you need to specify the transit gateway ID, which is a shared database attachment, which includes shared database attachment, and it is depend on the shared database attachment. Next, again, we will enable the connectivity from shared database to web app VPC. So again, this step is similar to previous one. So just give the route table ID, destination, CIDR block. Make sure that web application CIDR block is 10.0.0. So make sure that it is correct. Then I can give the transit gateway ID and the depend on. So basically this code will enable communication between the resources in these three VPCs to the connectivity managed by the transit gateway. So we have successfully edited the route table of the web app VPC shared database and as well as backend services. Now our next step is to apply the configuration. So let's apply the configuration and check all the applied resources are listed on AWS console or not. So just click on Open Integrated Terminal to apply the resources. Just type. So first command to initialize all the provider plugins. So just type here Terraform init command, which will initialize the backend. So our Terraform has been successfully initialized. Next, we are going to type the Terraform plan command, which will give an idea what are the resources going to create in our AWS console. So this will give an idea. So here you can see plan 31 to add. So 31 resources are we are going to create now. And as well as here you can find the outputs where I have mentioned earlier in EC2 web app and in EC2 shared database below the output of the instances created in their own VPC. Next step is to apply a configuration auto approve, which will approve the permission. So this will apply a configuration on an AWS account. So it will take around 5 minutes to create all the resources. So here you can find that our apply has been completed and 31 resources have been added successfully. And in output section here you can find the IPs for the respective EC2 instances. So let's copy the first IP address for web application. So let's check as we have entered the script. So here you can find our script have been working successfully. We have installed the Nginx and just we have get the host name and the IP address of the web app successfully. Now let's check for backend services. And then share database. So therefore our user data script has been worked successfully. Now let's check. The next step is to verify the connectivity between the VPC. So we will connect the EC2 instance and simply we will use the curl command to check the connectivity. So simply copy the web application IP. So before that, let's check AWS console and first check the VPC, the resources which we have created. Let's check one by one. So this is our VPC default page, VPC dashboard. So here you can find our VPC have been successfully created. And if you go in the route table, select the web app route. So here you need to understand that we have created the attachment to the VPC of backend as well as shared database for the web app. And here you can find all the attachment and the route table for backend services. Here we have created the attachment for web application and for shared database. And similar to this, for shared database, we have created attachment for our web app and backend services. And we have also created internet gateway to enable the internet connectivity. So that's why our EC2, that's why our public IP has been running. Visitors has been running. Next, we will check for the transit gateway. So below here, you can find the transit gateway. And if you click here, you can find that we have created only one transit gateway, but we have created the attachment, transit gateway attachment to enable the connectivity between the three VPC we have created, which is web app, backend services, and shared database. So here you can find our resources have been successfully created. So let's move on to our next step is to verify the connectivity between the VPC. So let's go back to console and select your EC2. Let's check the EC2 instance. So here you can find three EC2 instances have been created in their respective VPC, three VPC. So let's copy the first instance IP address and so this is mob exterm tool. So we will connect that instance by using mobexterm tool. So, and in advanced setting, just enter your key pair name. So now we will just type the curl command. So go back to the instances and select backend services. Let's check attachment from web app to backend services. So just copy the private IP address. Just type your curl, paste here. So here you can find we have successfully connected web app VPC to our backend services. Now we will check with shared database. So go back to the instances, select shared database, select private IP4. So just copy this and again. So due to network connection, it is getting timeout. So here you can again see that we have also enabled connectivity from web app VPC to the shared database. So you can see now let's check for the shared database only. So simply now connect the EC2 instance to the shared database. Specify the username as Ubuntu. Use private key, use web app key, and then select open. Now simply type the curl command to check the connectivity. Now check the connectivity from shared database to web app and so perfect. Now let's check for the backend services. Type the curl command. So here you can find that we have successfully connected to 3 VPC using Transit Gateway. You can also check it for backend services. Now, our next step is to delete all the resources created. So to delete all the resources, so just we will clear the screen. So to delete all the resources, just type Terraform destroy. So it will automatically delete the resources. So in manual setup, you need to delete one by one all the resources, but with the help of Terraform, it will destroy all the resources at one time. So here you can find it is in deleting state. So all these steps you can refer from the article available on posttechnics.com. So it will delete all the resources. So it is showing error. So again we will do so is showing error due to internet connectivity. So it will automatically destroy. So let's conclude for today. So in conclusion, leveraging Terraform for AWS VPC Transit Gateway setup streamlines network management, enhances VPC connectivity, and optimizes resource accessibility across multiple VPCs, ensuring efficient and scalable infrastructure deployment. So thank you for watching my video, and please do like and share the video, and don't forget to subscribe our channel. Thank you again and see you in the next video.